combining like terms and laws of exponents. First of all, an expression is a mathematical phrase that contains operations, numbers, and or variables. Can somebody tell me what the difference in an expression and an equation will be? An equation has an equal sign. If there is no equal sign in the problem, there's not going to be an equal sign in the answer. Does everybody understand that? Okay, so if you're doing an expression and you've got a bunch of x's and a bunch of numbers, you're not going to end up with x equals 7. You're not solving that. You can only simplify expressions. You cannot solve expressions. Okay? A term is part of an expression that is added or subtracted. And the coefficient of a term is the numerical factor of the term. Where does a coefficient appear? Does anybody know? It is in front of a variable. So if you have 5x, x is your variable, 5 is your coefficient. Okay, it's just the number in front of the letter. All right? Identify the coefficients in constant term if they exist. Okay? First of all, let's talk about, we'll get to that in a minute. Okay. Which part of this does not have a variable on the first one? The -1, right? That is your constant. Okay? Your coefficients then would be what? 2 and 3. All right? Look at letter B. What is your constant? 14. Do we have any coefficients? No, we don't have any letters, therefore we can't have any coefficients. All right, take a second and see if you can do C and D, and we'll check them. Can X be a constant? No. If it's an X, so it does have a front of it. All right, do we have a constant in number 3? No, there's no number over here without an X. So what are our coefficients in letter C? Thank you. 1, there's an understood 1 in front of that x cubed, and the other one is 12. It's an understood 1 in front of x cubed. If I say x, how many x's do you have? 1. Like if there's just a...
I see 2.
But I'm saying, if you just see x, how many x's is that? 1. It's 1x. We don't write understood 1s.
Oh, okay.
All right, so on the last one, is there a constant? No, what's our coefficient? 5. All right, so down here we're going to talk about different types of expressions, okay? Different types of what we call polynomials. All right, monomial has the root word mono. Anybody have a clue what the actual root word mono means? 1. It is one term. Okay, which one up there, A, B, C, D, could be one term? D, what else? B. D and B are both one term. All right, binomial is what? 2 terms. So that will be like C. C has 2 terms. It has x cubed and it has 12x. A trinomial is 3 terms. So that will be like letter A. All right, and a polynomial is basically anything after 3, or poly means many. All right, now here's where people go wrong. You do not label it monomial, binomial, or trinomial, or polynomial until you have simplified. Okay? So what I mean by that, and this is not on your note sheet, so just pay attention. All right, if I gave you this right here, right now that looks like a trinomial, right? But I can combine 5x minus 2x and get 3x minus 7, which is now a binomial. You label it after you simplify. Okay?
Oh, my bad.
I just made it up. I told you that's why I can't cheat, because I can't copy. All right, so here we go. Simplify the following expressions by combining like terms. Then we're going to label according to the definitions. Okay. You can only combine like terms if they have the same letter and the same exponent. All right. So I'm a color person, so use association. All right. So for instance, what are my two things that are alike in letter A? -7 and +2. So I'm going to combine -7 and +2. What does that give me? -5, and I'm going to leave my 3x there. So I have simplified that as far as I can go, and now I can label it as a binomial. You don't have to write the whole word. You can abbreviate. You all right over there? All right, so what's going to be alike in letter B? 2x squared and -3x squared. So what is 2x squared minus 3x squared? All right, now, you can write the 1, but you don't have to write the 1. If you write the 1, it's okay, but understand on your EOC, it won't be there. It's not, we don't write understood ones. So -x squared. Can I combine anything else? No, I have a 5x, and I have a 1. That's as simplified as that term can get. So this is a trinomial. Okay, if it cannot simplify, it's just done, and then you label it. All right, so y'all take a second to see if you can work on C, D, and E. D will be the hardest one, I'm sure. Could you simplify C at all? No, you couldn't put anything else together. So this is just your answer right here. And then what is it? A binomial. Right, letter D. What's a like? Okay. All right, the 5x squared y squared and the negative 2x squared y squared. What's 5x squared y squared minus 2x squared y squared? What's 5x squared y squared minus 2x squared y squared? 3, and then we leave the x squared y squared. Sorry, it's a mouthful. All right, and then we've got 3x squared y to the 4th. Okay, so because that second one has a y to the 4th, it was not a like term. Okay, so now this one is a monomial, binomial, trinomial. It is a binomial. Okay, to figure that out, y'all, don't worry about how many letters and all that. Kind of look at your plus signs. Each one of these is a term. It'll be separated by a plus or a minus. Okay, all right, and on the last one, letter E, what's a like? 3x and negative 5x. What's 3x minus 5x? Negative 2x. And what is 2y plus 6y? Positive 8y. Okay, real quick lesson on just operations in general. You can have that written backwards. You could have 8y minus 2x, and it would be the same. As long as your signs are the same, the order does not matter. Everybody with me? Okay, whether you do 2 plus 8 or 8 plus 2, you still get 10. Okay, order doesn't matter as long as your signs are the same. And this is a binomial. All right, easy enough on combining like terms. Everybody good? All right, let's go and do some exponent rules. Okay, most of y'all have seen your exponent rules before. We will drill these and drill these and drill these all semester long. All right, you can only add or subtract terms that have the same exponent. That's what we just talked about here. I could only add these that had the exponent of 2. Okay, I couldn't add the ones that didn't have an exponent of 2. You can only add or subtract when the exponents are the same. Okay, multiplying. If you multiply 2, you add your exponents. Okay, dividing. If you divide 2, then you're going to subtract your exponents. And then a power to a power is our last one. And that is where we'll actually multiply our exponents. Okay, so the first thing I want to do here is let's just look at that. Let's look at the top row, numbers 1, 3, 5, and 7. Okay, let's look at the top row. And I just want to look at the problem, and I want you to tell me, are we adding, subtracting, multiplying, dividing, or power to a power? So what do you think, number 1, we're doing? We are adding our terms, right? All right, what about number 3? 2 parentheses side by side is multiplying. What about number 5? We're adding again. And what about number 7? Okay, it has that power outside. Okay, anytime you see the 2 little exponents side by side, that's a power to a power. So that's going to kind of help me with referring to what I need to do. Okay, if I'm adding, do I add my exponents? No. So what is 1g plus 9g? 10g. All right, what do you think I need to do first in number 3? Multiply. What's 9 times negative 2? Negative 18. And what are we going to do with our exponents? Add them. 4 plus 3 is, so c to the 7. All right, do number 5 real quick, and then we'll talk about number 7. Okay, could you do anything in problem number 5? Did anybody add those and tell me it was 11J5? Why can't we add them? They're not the same exponent. Can you do anything else any further? No, it is just your answer. 2j squared plus 9j cubed. This is one of the biggest problems that I have found in math class is we start to teach you something, right? And you're like, oh, we added on number 1. So without even looking at the whole problem, you go ahead and add on number 5 without even recognizing, just because that's what we've been doing. Okay, so make sure you pay attention to each problem individually. All right, for number 7, the way that we do a power to a power, I'm going to kind of write it down here so that you can see. Anytime you square something, that's the same thing as multiplying it what? Times itself, right? Okay, so basically that's what I'm going to do. I'm going to go ahead and I'm going to square 4. What is 4 squared? Okay, so I'm going to write it out like this. And eventually you'll get to where you don't have to write it out like that. But you told me 4 squared is 16. And then it told me in my directions up here, for a power to a power, we multiply our exponents. So what is 8 times 2? A to the 16th power, and 3 times 2? B to the 6th. Yes, ma'am.
So we don't square the exponents?
Right. You square the big number, or whatever power it is. It might be a 3 or a 4. Okay, and then you multiply your exponents. So that was 16, A16, B6. All right, bottom row. What are we doing on number 2? Well, kind of both. When we divide, what are we going to do with our exponents? We're going to subtract. All right, what about number 4? Adding or subtracting. All right, number 6. Power to a power, and number 8. Multiplication. Good job. All right, so here, what do you think I'm going to do to my big numbers? I'm going to divide. What's negative 35 divided by 5? Negative 7. All right, and I subtract my exponents. Okay. So Megan, just like we talked about the understood 1 in front of an x, if there's no exponent, it is an understood 1. Don't forget that. That is a common mistake. So this m has a 1 right here. So what is 10 minus 1? 9. And is that an 8? 8 minus 3 maybe? Is 5. All right, what's the first thing I'm going to change in number 4? That double negative, I want to make a positive, right? So what is negative 20g to the 8 plus 4g to the 8? Negative 16. Make sure you keep your g to the 8. You can only subtract because they are the same. All right, power to a power on number 6. So technically what I'm going to do is 8 squared and then 8 times 2, right? What's 8 squared? 64. M to the 16. And number 8, pretty easy. What do I do first? 4 times 6 gives me 24, and add my exponents, w to the 8. All right, I'm going to give you a few minutes to work on these 6. Once we get done with these 6, we need to try to take your quiz for today. So we'll go over these 6, and we probably won't get to these 3 right now. Okay, so take a second, work on these 6. All right, what you got for number 1? Okay, it's an add or subtract one, so it is just negative 7 x to the 4th. All right, number 2, what are we doing? Multiply, what's 5 times 12? 60 x to the 8, because we add our exponents. All right, number 3 is also a multiply. So we're going to multiply 4 times 3. 12a to the 9th. All right, what's number 4? Power to a power. So we're going to square 5. What's 5 squared? M to the 6. Good job. Is everybody good on 1, 2, 3, 4? Pretty simple. Add, subtract, multiply, divide. Just know what you're doing with your exponents. All right, what do I need to do for number 5? Combine like terms. What's 10x plus 1x? 11x. So 11x minus 12x is negative x. Or you can do negative 1x. Either way. All right, where am I going to start in number 6? Multiply 5 times 2. 10. What do I do to my exponents? Add them, which makes it 9. Minus, what's 3 times 5? 15. X to the... Am I done there? No, I have like terms now, so I need to go ahead and subtract. What's 10x to the 9th minus 15x to the 9th? There you go.